What is an unbiased estimator, and why is it so crucial in the world of statistics? Well, let's dive into it. An unbiased estimator is a statistic that, on average, hits the bullseye. It's expected to equal the real value of the population parameter it's trying to estimate. Picture this. If you repeated the sampling process over and over, calculating the estimator each time, the average of these values would be the true population parameter. This stands in stark contrast to a biased estimator, a statistic that consistently overestimates or underestimates the true value. There are several conditions that can make an estimator biased. One common culprit is the sneaky sampling error. This is the discrepancy between the sample mean and the population mean, a difference that can occur due to random variation in the sample that doesn't quite capture the entire population. Another source of bias is the use of non-random sampling methods. Methods like convenience sampling or quota sampling can lead to biased estimators because they don't give every member of the population an equal shot at being selected. This can result in a sample that leans towards certain groups, leading to an off-kilter estimate of the population mean. So, how can you reduce or eliminate bias in estimators? One common strategy is to use random sampling methods, like simple random sampling or stratified random sampling. These methods make sure every member of the population has an equal chance of being chosen for the sample, which helps reduce sampling error and bias. Another strategy is to use weighting methods. These involve giving different weights to different observations in the sample based on how likely they are to accurately represent the population. This can help balance out the effects of sampling error and bias. Finally, it's important to think carefully about the type of estimator being used. Some estimators are more susceptible to bias than others. For instance, the sample mean is a pretty unbiased estimator, while the median can be biased if the population isn't normally distributed. In general, unbiased estimators are more desirable than biased ones because they're more likely to give accurate estimates of the population parameter. But it's crucial to be aware of the potential for bias in estimators and to take steps to minimize it whenever possible. So, to recap, an unbiased estimator is your best bet for accurate results. Be aware of potential sources of bias, like sampling error and non-random sampling methods, and use strategies like random sampling and weighting methods to keep bias at bay. And remember, not all estimators are created equal. Choose wisely to get the most accurate results.